things which they'll be used in the case of the target variable. And coming on with the training data. So part of a data they will be using for the training purpose, and the part of the data they'll be using for the testing the data. So in the case of a training data, so normally if we have 100 data, okay, the one way of making the model. So the one way of making the model is they'll be having like 100 data in sense 100 records, okay, 100 records. Out of this 100 records, 75 records will be with properly, like all the data will be present and will be with the target label, and it will be given to the model, and the model will be trained, okay. And remaining 25 data will be used for the 25 records, okay, 25 records will be used for the testing purpose, so where the target may not have the value, and based upon the experience gained, okay, based upon the knowledge gained with the help of the 75 training data, we'll be getting the values of the target in the testing data. So rest of the 25 data will be getting the values. It will be, we can predict the values. That's what they're trying to say over. So these are the normal things. These are the normal keywords that will be used in the case of the machine learning. So training data and then the testing data. So why we need to perform this AML? What is the purpose of this? So it increases in data generation and uncovers the patterns and trends in the data, and solve the complex problems and improve the decision making. So these are the various reasons why we normally go on with this ML process. So to put in like a very precise manner, so first we should define the objective of the problem statement. So why are we doing this particular ML, or why are we building this model? So that is going to be like in first step. And the second step is we are supposed to gather the related data based upon the objective. So what data is there and how we can retrieve. So all those things will be done. And the third is after collecting the data, definitely the data may not be may not be like all the data, all the fields may not be present, few may be missing over there, and few may be duplicated over there. So all this needs to be done, all this needs to be taken care, and that particular phase is called as pre-processing. Okay, so now as I said in the beginning, we have 100 records. Okay, so in this 100 records, here and there few missing values are there. How am I going to manage those missing values? Am I going to input, like am I going to key in some value? So it's not possible when the record is very few. So for example, it is going to be like 30 attributes. Okay, so 30 attributes, and 31st attribute is the label, and we are having like 100 records. So you can roughly imagine like a tabular column, where in the tabular column we are having the 30 columns, and the last 31st column is the target label. And similarly we are having the 100 records, so 100 multiplied with the 31. So many fields are there, so many small boxes are filled with the values over there. If any of the values are missing over there, how am I going to fill it over there? So in few cases when there are so much of missing, they may remove that particular record completely out of this 100 records. They may remove that completely the particular record, or in few cases they'll be trying to input the input the minimum value or the average value or the maximum value, or based upon the model some values will be inputted. So that's the process of handling the missing value. So that's a very important phase of the, because that is the one which decides the how far the data is reliable in nature, and similarly how they will be handling it to remove the duplicate value. So these are the things which happens in the case of the data pre-processing, and they may be called as a data preparation. Okay, so then like once we found this data, then now the data is ready. So the next step is like we need to visualize the data, how the data is there, how much distribution is there. So if as I said, like now we are having the 30 attributes. So out of these 30 attributes, like example, it is having an attribute like a gender, or it is having an attribute or like an age, and it is going to have an attribute like a demographic area, the location of the people residing over there. So based on this I can get over some understanding. Okay, so like a 60 gen record is there and a 40 female record is like that information is, and then like okay, so much of a gen participated in this, so some sort of interpretation could be got over. Like that's what it's done in the case of the exploratory data analysis, understanding the pattern and the trends over there. And after that we can build the model. We are having n number of algorithms for the machine learning. So based upon the type of the data, so if the data is going to be like completely labeled or it is unlabeled in nature, so based on that we are having n number of the models, and we can build the model using that. So and after the building also, inside that each and every algorithm we are having number of parameters which could be fine-tuned to ensure we are having the higher performance. So higher performance in sense, in the case of the classification, accuracy. Okay, in the case of the first parameter which we'll be considering is accuracy, and other than that we have the precision, recall, all those things are there. So the what is going to be the ideal value, so based on that we'll be fine tuning this value set of parameters. And again, in the case of this model building also, we are having 2 or 3 methods, right? Normally we may be going like it, a part of the data, 3/4 of the data as a training and 1/4 as a testing, or otherwise we'll be going on with a cross-fold validation, like 5 folds will be keeping that, and each and every time the set of things will be going on at the training and set of things will be going on at the testing. So there are a number of methods for this cross validation also. Okay, and the last 3 words like prediction, regression, clustering, we can just see about like what they try to convey. So what are the types of machine learning? Is supervised machine learning, unsupervised, semi-supervised, reinforcement learning. So in the case of a supervised learning, records, all the records will be perfectly given with the label or with the target values. Okay, so in the case of the, so obviously it falls in the supervised where everything is very clearly given over there. So you can see here, so for every data instance we have the input X and then output Y. Given a new observation X, this model will try to find out the output Y over there. So a label data set, it's very perfect in the neat data set where we can create the model based upon the input and then output, and when new input enters, for that we can predict the output. So this is like prediction or the classification. Okay, and coming on with the supervised learning, so based upon the target label, when the target label is so specific, and then it comes under the classification method, categorical or discrete. So now we are discussing about, like I said, about the 100 records, let it be on one side. So now if we want to finalize, like based upon the values, I need to classify, I need to categorize that student education level is good, bad, or average. So I am having like in 5 marks, the value of the 5 marks helps me to find out whether that good, bad, or so there we have like a like definite target value. So that comes under the categorical or discrete, and we'll be having the classification. The other way is there's at times like the target value will be continuous in nature. So that time we'll be getting more in the regression. It's called as a regression sort of a thing. So where we'll be having like an y is equal to ax plus b. So where like x is going to be the constant, and a and b keeps on varying to get the y value over there. So there we'll be having the continuous values in the case of the target label. And coming on with the unsupervised learning, where the label will not be provided, and based upon the values of the data, we try to group them together. So we'll be grouping the records of similar together, and like a different will be grouped into another way. So that comes under the unsupervised learning or the clustering. Clustering stands for grouping. That's just unsupervised learning. So clustering, the steps of the problem, assigning the inputs to the 2 or more clusters based upon the feature similarity. And similarly, in the case of a semi-supervised learning, we are having the option of it's going to be like a mix and match of both the steps. So few things will be labeled and few things will be unlabeled. So based on the requirement, we'll be using over like an algorithm, and that will help in the classification purpose. And last type in the case of the machine learning is a reinforcement learning. So where the agent acting in an environment have to determine what actions that agents takes at every step, and action based upon the rewards penalties the agents gets at any steps over there. So it's based upon the agent's point of view. So now in the case of the orange point of view, you are much inside the inside the supervised learning method. So I'm just trying to give the general framework, like so we are going to input the data, and ML algorithm is going to be there, and training the data and training the ML algorithm, ML model. So evaluating, and then finally we are going to make the prediction for the test data point of view.
Video is not audible, ma'am.
Okay, it's not audible.
Yes, ma'am, it's not audible.
Oh, but it's audible for me. Okay, fine. Okay. So actually in this, no, like it will try to give an information like why data analytics required to be done over. So in the very previous years, like in the previous decades or the previous centuries, like we don't have the facility of the this data storing and all those stuff. So what happens is if you want to knew about like an status of the particular shop, we need to go and check and come, or we are not that aware about that. So, but in the recent years, use of this data analytics helps us to find out exactly in which particular location the particular item is stored over there, it's present over there. Is it present or not? So based on it, so hope we knew that common word called as an inventory control management. So all those are possible with the help of this. Okay, so let's the video, no worries. So that's what they're trying to show over there. So coming on with the various data mining techniques. So that's like in classification, association, and then the prediction, clustering, sequential patterns, decision tree. So these are the normal buzzwords in the case of the data. Hope it's audible and visible. Am I right, Professor?
Yes, ma'am. It is audible and visible.
Yeah, okay, fine. So coming on with this data mining techniques, these are the normal buzzwords like a classification, association, prediction, clustering, sequential patterns, and the decision tree. So now to a certain extent, you would have inferred like, so classification is mentioned for the target label. It's going to be like discrete in nature or categorical in nature, and regression is meant for the target variable is going to be continuous in nature. And in the case of the clustering, we don't have the target labels, and it is going to be grouping the things based upon the values of the features point of the view. Okay, that's the like I said. And the next one is an association. So association is like so which particular item will be associated with the other. So this is the way like our big shops are getting decorated. Like so which normally the persons will be buy after the other thing. So something like that will be happening. So I will put the link of that, I guess. It will take some time. Just a minute. So if anyone is link to download the orange I have given. So if anyone is interested and if they can download it in the meantime. Okay, so classification. So given a collection of records, the training set, each records contain a set of attributes. One of the attribute is the class. So they may call them as a class or the target or the label. Okay, and find a model for the class attribute as a function of the values of the other attributes. And previously unseen record should be assigned a class as accurately as possible. So that's called as a test set. So in the case of the training set, we'll be having all the values for each and every attribute, and we'll be having the target or a class or a label attribute. So that also be having the values. So what ultimately aim of the classification is, while we are going to give a test set that is not having the value of that particular class label or a target, that needs to be predicted and assigned over there. So that happens, that is the ultimate requirement. So it's going to be called, we can precisely call them as a prediction point of the view. Okay, so usually the given data set is divided into training and the test sets, with the training set used to build the model and test set used to validate it. Okay, and coming on with an example. So customer attrition churn or attrition or churn. Okay, so normally like we would have seen like in the real-time world, like while we like Jio entered inside the market. Okay, all the people who are in Airtel or a Vodafone or a BSNL, they started moving towards the Jio point of the view. Okay, and still like few people used to maintain in the same hole like an Airtel, BSNL or a Vodafone. Okay, so what are the attributes that made the people to move from the one telecom to the other telecom? Okay, so in the case of an Jio, they are given so much of freebies. Okay, they made so much of freebies. So slowly like people started using that. So like if I am right, they have given these freebies for a year or at the max like in 1.5 years. And then they also started charging for those things which they are providing, like a service providing sort of a thing. Okay, so for this, like now they have given an example in this particular scenario. We have discussing based upon this customer churn for the mobile point of the view. So a customer calls, where he calls, what time of the day he calls, and what is his financial status. Similarly, we are having n number. So the finally it's going to be having a stuff called as a churn. Churn is going to be yes or no. Is he going to stay back with the same organization, or he or she is going to move out of the organization? So based on that, we are going to make. So if it's going to be like an yes means, so what are the things, what are the values of the attributes that made the persons to stay inside the organization? So when it is going, when he or she is going to stay back, we will call them as a loyal customer. Otherwise, we can call them as a, they are not a loyal, disloyal, like customers are disloyal in nature. This is just an example. Like you can very well understand, like, so these are the various attributes. So based on the attributes, what is going to be like finalized point of the view. Okay, another very simple example. You can see here, like it's like in fish packing industry. Okay, so in the fish packing industry, by seeing the fish, like what they'll be getting like lump sum of fishes over there. So they need to divide that fish into like what type of the fish it is. So they are having like features like a length, lightness, width, and position of the mouth. So they are considering these features to map that fish either into the sea bass or a salmon type, whether the particular fish is a sea bass or a salmon type. So initially we need to code it, program it, and once it is programmed, then automatically when the fish enters, when the fish is placed over that optic scanner, it will be checking over like, and it will be diverting it to either the salmon type or the sea bass type. So that's, so you can very well see it. So pre-processing, the images of the different fishes are isolated from one another and from the background, and feature is extracted over there. So feature in sense, what is the length of the fish, what is the lightness of the fish, hope you can see here, what is the width of the fish, and what is the position of the mouth. So based on this, we are going to make over the decision, and then we are going to classify. So now what is the general knowledge is sea bass is generally longer than the salmon. Okay, this is like a knowledge, domain knowledge which we have. So now we'll be checking on with the length. So we had so many attributes. We thought like we can either go with the length or the lightness or the width or the position of the mouth. But now we are checking over with that, and we found like length is going to be higher for the sea bass, and then comparison with the salmon point of the view. So we are going to consider the length as an important factor over there. So what is the fish length and what is the fish name? So this is going to be like a table. So fish length, what is the fish length and what is the fish name point of the view. So now based on this, we are going to build a model stating like when the length is greater than so much. Okay, they're just starting over with the point. So when the length is so greater than so much value, L star is going to be some value over there that falls under the sea bass. Otherwise, it's called as in salmon. So it will be classified as in sea bass. Otherwise, it will be classified as the salmon point of the view. So they are trying to log in, and they see like various values like a 12 or a salmon, or a 15 or a sea bass, 8 a salmon, 5 sea bass, all the combinations. So finally, the model is built with the value like if the length is greater than 12, then sea bass, else salmon. That's it. So now it is creating a model. The model works on the principle like if the length of the fish is greater than 12, it falls under the sea bass type, else it falls under the salmon type. So now a new fish is coming inside that. I mean, it's coming for the package section, and they need to check this. They'll be checking the length. If the check is, I'm checking if they're getting like in 15, they'll be directly putting it as a sea bass. Okay, similarly, so that's a testing point of the view. So using this pre-processing feature extraction, I'm training and I'm getting the model. So model is built on the principle if length is greater than 12, then the sea bass, else it falls under the salmon type. Okay, and this is like model building, and then we'll be making the performance. Okay, another one example similar to this is, so now a person is trying to move for a new job. So before moving, he needs to make some decision over there. So he's taking like for salary is at least 50,000. He may think about going to the job. If not, immediately he's going to decline the offer. And again, if the commute is more than 1 hour, then he is going to decline the offer. It is less than 1 hour, then he is going to go for the particular job. And again, another one constraint is having the company is offering the free coffee. If it is offering the free coffee, then he will be accepting the offer, or else it is going to declining the offer. So here the 3 attributes are there. So first attribute is a salary amount, and the second attribute is a time for commute, and the third attribute is, are they offering the free coffee or not? So these are the three attributes. So for example, if a salary is 40,000, what happens in the initial stage itself? Offer will be declined over there. So now if, for example, salary is 60,000 and the commute time is like 40 minutes and they are offering the free coffee, then obviously it falls under the accepting the offer. So this is the way, like inside the algorithm they'll be working on, checking on with the values of each and every attribute, and then the final decision will be taken over there. Okay, and coming on with another one example, like so refund and then marital status, taxable income, or a cheat. So whether a person is a cheater or not. So they're trying to make that model for the fraud detection point of the view. So this is another one example. So all these are having the proper categorical value. Okay, proper category. Okay, proper category or the perfect value, so that all this falls under the classification type. So as I said earlier, when the values are going to be continuous in nature, then it comes under the regression type. Okay, so now we have seen about the classification and the regression. So this comes under the supervised machine learning. So where the target label is clearly given over there. So the performance measure which helps to know about our machine learning algorithm, whether the algorithm is the best or something like that. So we will be having this confusion matrix. So the confusion matrix is the one which gives us the information about how many things predicted perfectly, or how many things like which we say like it is correct or wrong, like whatever way it's predicted properly. So that's a matrix between the predicted values and the actual values, where the TP stands for the true positive and FP stands for the false positive, and the FN stands for the false negative, and TN stands for the true negative. So I am just leaving this to you, like true positive is observation is positive and predicted to be the positive, perfect it is, and the false negative observation is positive but is predicted as a negative over there. So based on these values, I think like you may know about all these concepts. So true positive, false positive, and based on that we'll be having the values for this performance measure, accuracy, recall, and precision, and then the F measure point of the view. So when all the things like a true positive and the true negative and divided by the all other records, so number of records over there, we'll be getting the accuracy, and similarly ROC. So ideal value for accuracy is it should be higher. 100% is a top value, and it should be nearing like above 90 or above 80. It's going to be like a model is perfect in nation. And recall and the precision and the F measure value are normally between like a 0 to 1. So 0.889 or 0.99 is considered as an ideal value in the case of the recall, precision, and the F measure. So based on the area under curve, we'll be building this ROC, receiver operating characters. Obviously the LO is called as an excellent, which tries to reach over like an 1 point of view. So these are the normal performance measure which we will be using in the case of the classification, or precisely we can call them as a supervised machine learning algorithm point of view. Okay, and coming on with the clustering. So now we have seen about the classification, and the next one which we are going to discuss is a clustering. So as I said earlier, in the case of the clustering, we don't have this target label, but we'll be having the data where based upon the similarity, we will try to group the data over there. Okay, so this collection of the data objects and similar to one another will be within the same cluster, and dissimilar to the object in the other classes, and it falls under the unsupervised classification. And given a set of data points, each having a set of attributes and the similarity measures among them, find the clusters such that the data points in one cluster are more similar to one another, and data points in separate cluster are less similar to the one another point of view. And obviously this is used to make over like a decision in the case of a marketing, which particular area will be suitable for this particular stuff. All those things could be done. And similarly land use, and then insurance, and then the city planning and earthquake studies. And what is a good clustering is, it's a high intra-cluster similarity and low intra-cluster similarity comes, it's considered as a very good clustering in the case of the clustering point of view. And association rule mining, as I said earlier, it's going to be like customer who bought X also bought Y, to find like relationship between the attributes over there. And the other name is like a market basket analysis and the affinity analysis. And if this is exists over it, then this is possible. That's what like an antecedent and then are you able to hear this video? Hello?
Ma'am,
Are you able to hear this, ma'am?
audio is not coming from the video here. Yeah, yes, ma'am.
Let's check what is the reason. It is full. Okay. I'm not sure what is the reason. Okay, it's fine. Okay, so here they're trying to show about like how much of data is used each and every second or minute point of the. That's small. Okay. Okay. So coming on with what are the various other open source tools which you can check on later on apart from the Orange. So Orange is like an I guess it's really wonderful in nature and it is open source and it's just a perfect software suite for the machine learning and the data mining. And it best aids the data visualization and it is a component based software. And coming on at the Vika, and this is also like a nice open source tool and it's developed by the University of Waikato in New Zealand and it's best suited for a data analysis and predictive modeling stuff and it was developed in the Java programming language. Another thing is in a K9, it's open source and it's best integration platform for the data analytics and RapidMiner is there and similarly Apache Mahout is there and Data Melt and then Metabase. So all these are available and we can definitely use any one of the tools. Another is an open refine tool. So where it is purely, it's preliminary meant for the pre-processing of the data, present data over there. And Talent, so it's an open source integration software provided to data-driven enterprises. And these are the various open source tools which you can use. And my suggestion is like to just know the concept behind those things. We can first check on with the Orange and Weka. Okay, so both these things could be so ideal for the very beginner's point of view. But obviously, the coding could be done with the help of the Google Colab. It's not required like only Anaconda requires to be used for the coding point. In the case of a data, using the Python over there, you can use a Google Colab where it is very user friendly in nature, such that it's not required to pip install each and everything like separately. It goes on a single flow together. Okay, so then coming on with the other thing, it's data repository. So it's instead of it's not enough only to know about like how to work with, but we need to analyze like how to take over the data over there. So this is one data repository, Kaggle. Just you can check over like a data here, but normally in the case of the paper publications, they are not accepting this Kaggle data because anyone can upload the data. There is no restriction, so anyone can upload the data. So normally in the case of the papers, they are not considering this Kaggle data set and very common and so very old data set repository is UCA data repository. Here we have n number of data repositories and here it will be giving us information like whether it could be help for the classification or it could be done for the regression. All those information will be given in the UCA data repository. And this is a KNUMA data set. It's like an Indian data set and Keel is another one where it has both the classification and the data sets too. And similarly data science and other popular things are like you can check on with the Mendeley data set. Okay, Mendeley data set, they are considering it as a benchmark data set. And again, it's getting updated very frequently. And the other common thing which we can do is Google data set. In the Google data set itself, we can just key in like an area of the work and we can see n number of data sets in this. So to put together all the things, the training. So in the case of the training, we have the label and input is given which are the feature extraction and feature and the machine learning algorithm is built. In the case of the prediction, we have the input but label is missing. Okay, we have the input but the label is missing and we'll be extracting the features and based on the model built over there, we will try to get that label. Hope you can see that in the training we had the label on the top, In the case of the prediction, the label is shown towards the end. Are you able to see that? Yes. So this is like a very concrete way of representing the workflow over there. So training will be having the label. Using that label, they'll be making the model. And in the case of the prediction, it will be help to get the values for the label over there. Okay, so now let us enter inside like one data set. And with that particular data set, we will go on with the further inferences. Okay, so here it is like to find whether a person is having the heart disease or not. So we are having the 14 attributes. Okay, we are having the 14 attributes. And out of these 14 attributes, 13 attributes are called as an predictors, okay, like, and 14th is going to be like a target point of view. So what is an age, and then what is the sex, and what is a chest pain type, and then what is going to be the blood pressure, what is the cholesterol level, and what is the blood sugar, fasting blood sugar level, and electrocardiographic results, and then maximum heart rate, and then exercise induced angina, and then all this 13 will be having the values. And the 14 is the like a predictor attribute or a diagnosis of the heart disease, whether a person is having the heart disease or not. So so all this will be having the values, and it falls under the only two type: is he having the problem or he is not having the problem. Okay, so this is like an example data set which we are going to consider further. Okay, as of now, let me pass. I want to hear from your audience any query till this. Any queries?
Ma'am, you can proceed, ma'am.
Okay, fine. Now, so this is like an like we fastly gone through like what are the concepts behind the data mining. So next we can get enter inside the Orange tool. Okay. So this is the first. Let me. Are you able to see the Orange tool PowerPoint? I guess
Only
no.
the last slide of your
Okay,
previous
fine. Yeah.
PPT only I got, yes, fine.
Pass share, new share, Orange. Now you can see Orange tools, right?
No, ma'am.
Yeah.
No, ma'am, it is not visible. Only last PPT only visible.
Thank you is visible, is it so?
Yeah, yes, yes, yes.
So now I have changed. Now I have changed. Hope someone can see. Orange tools. Stop share.
Participant, you can respond.
Yeah. Orange tools.
Yes, ma'am.
Yes. Okay. Fine. Yeah. So before
Ma'am,
we are
they are
entering
posting the
inside.
queries in the chat room.
Okay. Okay. Fine. It's not a PPT. Okay. Can we get it? Yeah. Sure. Sure. Okay. So Orange tools. So Orange is a collection of Python. So if we have the Anaconda, inside the Anaconda also we have the stuff for the Orange. But for the ease of the user, like I feel like we can just go on with an Orange independently, as I shown in that web link. You can download that and you can. Yeah, ma'am. Anything?
No, ma'am. No, ma'am.
Okay. So it's an open source, and we'll be having like in widgets, provide a graphical user. So I'll show where to open that also. So graphical user interface to Orange's data mining and the machine learning methods. And other features of the Orange's open and the free software, and platform independent software, and its programming support and its scripting interface. It started in the 1997 in the Bioinformatics Laboratory of the Faculty of Computer and Information, Slovenia. And in 2005, slowly it got, I mean, it's with so many widgets and so many things, it start evolving, and no programming needed, and basically visual programming, and we can have the effective data visualization, and easy to try different machine learning algorithm, and various add-on available like bioinformatics, network analysis, and the text mining, and it's free and open source software. And from here we can download this Orange. Okay, so the view of the Orange is, once you open that Orange, it will be in this particular manner. So new, open, or recent, or get started. So we can go on with the new, and the left side you can see the widgets where a data, visualize, classify, all those things will be there. So in the case of the data, okay, in the case of this data, we'll be having this file to input the file, and then are we going to save it, like are we going to sample the data? And you can see one tab called as an impute. Okay, in the case of an impute, it will be giving an option of putting the minimum value or putting the average value or putting the maximum value, all those things could be done with that particular icon. And similarly, outliers could be found, and we can go on with the feature constructor. So, and so many things are there. So you can download and slowly you can start working and see. Okay, and in the case of the visualize widget, these are like in few visualization steps. So it shows the distribution of a data set, how many male, how many female, or those distributions, or attribute statistics it will be showing, and it will be having the scatter plot. All those things is possible. So these are the various visualization steps that could be done. And coming on in the classification, so hope you can see that various classification. We can apply the Naive Bayesian algorithm, we can apply the logistic regression, we can apply the neural networks, and similarly we can apply CN2, random forest, classification tree. All these things could be done. And when we apply the CN2 to view the rules, we can use a CN2 rule viewer after applying it. So similarly, we can make use of all the algorithms. And coming on with the regression, linear regression method, SVM regression method. So as I said, in the case of the classification, the target is going to be categorical in nature, and it's going to be fixed in nature. In the case of a regression, the target is going to be continuous in nature. So that's the regression. And similarly, in the case of an evaluate, so we can have this performance measures, accuracy, precision, recall with the help of this test learners, and predictions could be helped to find the value for the test data. And the confusion matrix obviously gives us true, positive, true, negative, all those values. And ROC analysis, so which I said the ideal value is nearing the 1. So that's ROC analysis. And similarly, lift curve and the calibration plot are the other things for the evaluation purpose. And coming on with an unsupervised algorithm, so unsupervised means clustering. So clustering could be done, distance map, all these things. These are the various features in the case of the non-supervised. And similarly, in the case of an association, we'll be getting the association rules, and which are like a frequent item sets. All this could be achieved. And so these are like an basic things that is present in the case of the Orange tool. Apart from that, we are having a provision to make over like an image analysis also. We are having the provision to make the image analysis, and we are having a provision to go on with the bioinformatics data sets. We are having the provision to go on with the natural language processing. So all these are there with the okay, so let me close this Orange. So let's center inside the Orange. Okay, so I said I will show you the I like to share the entire screen actually. Basics. So I guess now nothing is visible, right?
Yes, madam.
Nothing is okay, fine. I want to show this. Yeah. Okay.
Yeah, it's visible.
Yeah, now it's visible. So this just take this. So this is one like which was downloaded. Okay, Orange 3. So if someone would download it, you can see this. So this is in the zip file. And if you unzip it, and if you just click this Orange shortcut, okay, if you just click this Orange shortcut, the Orange will be open. Okay. Okay, so I have given the information like how to work. I mean, how to. So anyone install the Orange? Anyone at least? Have anyone installed? Participants, please reply me.
Yes, ma'am, it's installed already.
Okay, fine. Okay, so we have to take the file, or we can go on with the CSV file. So CSV stands for the comma separated value format. So as I said, so data is there, and it's like for the transforming, and then visual left side I'm showing visualizing purpose, and these are the various models for the classification point of view or a supervised learning point of view, and this parameters helps for the evaluation, and this is meant for the unsupervised learning. Okay, so coming on with the data. Okay, let me take the CSV file. So our hard disk is in the CSV file format. Let me take the CSV file, and I'm going to load that particular data set. Heart. Okay. So you can see here, it is having 303 303 records. Okay, it's having 303 records, and in this like in 14 aura features. Okay, let it be one side. Let's go with the file. Yeah, connect it. Okay, again I'm going to reload it. Reload it. Heart. Okay, so if you just just insert in this file format, you can see what is the role of this. So in this, as I shown in the last file of the last PPT slide, age is there, which is in the numerical, and then sex is there, which is going to be categorical, male or a female, so 0 or a 1, and then similarly CP type in the numerical. So now our target is target. Okay, the name in this particular data set. So it is having we are having the various rows, and I'm assigning the target to this target variable and apply it.
Ma'am?
Yeah.
Ma'am?
Yeah.
It's not visible, ma'am.
Not visible. It's in the sharing only, ma'am. Hello.
Hello?
Is visible, ma'am.
Yeah.
Visible.
Yeah, we are
Okay.
able to see, ma'am.
Okay, ma'am. Okay.
It's visible?
Yes.
Yes, okay. So now I have imported the file. Okay, now I've imported the file. I'm just viewing the file now. After importing, I'm just viewing it. Using the data table, I'm going to just view it. So the attributes which I said, more hide floating meeting controls. Okay, so you can see like target is on the first column, and after that followed by the age, sex, CP, trespass, all those things which we have seen in the PPT slide, all the attributes are there. So
Sorry
it is
for
showing
interruption, ma'am. Screen is not.
Yeah,
Screen
the
is not
screen is not visible, ma'am.
the orange is also not visible.
It's just a blank screen, ma'am. I couldn't see anything.
Couldn't see anything. Actually, I'm
Yeah.
trying. We have the option like showing the entire screen in the orange. Actually, I'm just trying to see
Now it's
that.
okay. Now it's okay. Now it's okay.
Now, but we need to show the other screens also, no? Like entire desktop option I'm trying to see, but I'm not able to find out. Ma'am, I will just move out of the Zoom and I'll come back again, ma'am.
Okay, ma'am.
Okay, just a minute, ma'am, because I guess some properties are missing. I will just log in via my Zoom and I'll come back again, ma'am. Just a minute.
Okay.
Kindly provide me the share screen option.
Yes, Karthik.
Yes, ma'am.
Provide me the share screen option, sir.
Ma'am.
I'm not able to share my screen. Kindly provide the share screen option.
Yeah, sure. Yeah, now you can share.
Yeah. I want to share the entire screen actually.
Yeah, now you can share, ma'am.
Yeah.
Given
But
the
it's not providing that provision actually. Entire screen.
Dr. Sujata Radhakrishnan.
Yeah. It's fine, but I want to share the entire screen. I'm just trying to do that actually. That is possible
We'll
now.
make you as a host, ma'am. I will make you as a
What's
host.
that?
We'll make you as a host, ma'am.
Yeah, just make it, sir.
Host, main host. Okay.
But still.
Now, yeah, now you can share, ma'am.
Actually, now I'm trying to it's over the data table. Arrow is over the data table, right? Sir.
Yeah, yes, ma'am. Yes,
Yes.
ma'am.
So if
File
I
is-
click it, actually I'll be another one data table will be opening. Is it visible or not? I guess it's not visible.
Yes, ma'am. It is
Yeah,
not
so-
visible.
Yeah, the problem is like it's not providing the provision for the entire window option. Advanced sharing option. Just a minute. Multiple. Who can share? All participants? No, it's not there. Normally we have. I don't know like how we are not having here. Someone can help me in this.
Karthik.
Like I want to share the entire screen actually.
Ma'am, just to go to the share option, ma'am.
Yeah.
There is an option called share entire screen.
Yeah, but it's not showing to me. That is the problem.
Yeah, let me show the demo, ma'am. Yeah.
It's just sharing on the window basis. That is the problem.
Yes. Desktop. My desktop. I have shared the entire screen.
Yeah, but it's not showing in my stuff.
Yeah, ma'am, there is an option, ma'am. When you try to share, there is an option on the left hand side. First option is the option for desktop, ma'am.
Okay. Let me check once again. Let me check from my system.
Ma'am, I reclaimed the host, ma'am.
Yeah, okay. Share screen. If you stop sharing, I can start. Okay, share screen and then?
And then left hand side, you can see the option for sharing the desktop, ma'am. Screen.
No, OS disabled me.
There is option called screen, ma'am.
Yeah, yes, sir. Now provide me the share screen option. Now I'm not able to. OS disable the participant screen sharing.
Yeah. Now you can see, ma'am. You click the new share. Are you able to see this? Are you able to see the screen, ma'am?
Yeah, I am able to see your screen.
Yeah, this is an option, ma'am.
Okay, sir. You just open. You just give me an option. I will just check once again.
Okay, ma'am. Yes.
Can I?
Yes, ma'am. Just a few seconds, ma'am. I will make you.
Yeah.
I'll change it.
Yeah. So see. No, I want the entire. I can see like if I'm going to click this
Yeah,
window.
ma'am. I can add some. You wanted to share the entire screen.
Yes.
Click the share screen button, ma'am. Then
I click. Hope you can see now.
In the window appears, you can see the screen option. Screen. The first option.
It's not showing to me. That is the problem.
It will not show for you, ma'am. If you share, it will be visible for all others. Just click the screen, ma'am.
Sir, actually,
Yeah,
it's
yeah.
not.
No, ma'am. Yes, it is. When you click the screen, you are not able to see your desktop, ma'am, in Zoom, but all others can see your screen. Just click the share screen option, ma'am.
Okay, share screen. Yeah.
In the window appears, there is an option called screen.
That option is not in mine. That is the problem. That option, it's not showing to me.
Because I made it as a host, ma'am. Now you are the host. You are a host.
Yeah.
To share.
But still, it's not showing. I can understand you are trying to, but it's not having that screen option which comes in your window, in your screen. Basic, advanced, and files. This is what it's showing in my end.
Yeah, ma'am. Let me show one more.
Are you able to see my screen, sir? Yeah.
Yes, yes.
Now I have the screen, ma'am.
Yeah.
Side, I have clicked the share option. This is a window to select the applications we wanted to share.
Yes, sir. But it's not
basic.
Providing me the entire screen option.
Go to the basic, ma'am. Go to the basic. Go to the basic, ma'am.
Okay.
You can find a screen option.
Okay, let me check. But it's not there. I don't know why. I normally used to
there
give
are
that
three
option.
tabs. Basic. There are three tabs, ma'am. Basic, advanced, and files. In the basic tab, you can see the first option is a screen option.
Okay, sir.
Okay.
But it's not giving the option for the entire desktop.
Yeah, ma'am. Log in again, ma'am.
Log in again. Okay,
let's make you host. Yeah.
Log out and log in.
Log out and log in.
Okay.
Ma'am, you are now. Ma'am, you are.
Yeah, basic, advanced files is there.
Yeah, go to the basic, ma'am. The first option is screen sharing. Is it there, ma'am?
Sir, it's not there. Okay, somehow I will try to manage the things. It's various screens are there, but not the entire desktop screen I'm able to. I don't know what is the reason.
Yeah, there is an option called a screen, but it's not visible on the website.
Yeah, fine. It's okay. Somehow let me manage it. We can't spend more time on this. Anyway, let me go on with window by window. There is no other go. Okay. So that's actually the interesting part. Only when we show those each and every snippets, it will be interesting actually. What to do? Advanced sharing options. Okay. Okay, just let me check once.
चालेल हा. हो हो चालेल काही प्रॉब्लेम नाही.
Karthik sir. Hello. இப்ப நம்மள இதை கொடுத்தா அவங்க வருவாங்க. என்ன கரெக்ட் தானே? Hello, Karthik sir. Hello. Hello. So others kindly input the data inside this orange. Actually, it will be very interesting. You can download any data of your choice from the Kaggle or from the
Yes, ma'am. Sorry, ma'am. I was discussing about the technical issue. Yes, ma'am.
Yeah, any desk. Kindly put the any desk, sir. Any desk and install that.
Any desk.
Install பண்ணிட்டீங்களா?
I'm searching.
My address is 455 107 849. Invite கொடுங்க. Four 55 107 849.
Ma'am, say it again, ma'am.
455 107 849.
455
107 849.
84.
Four 55 107 849. Give me an invite. Any desk தானே சார் போட்டீங்க?
Yes, ma'am. Any desk தான் போயிட்டு.
ஆனா வரல எனக்கு.
We have to download, ma'am.
Yeah, any desk download பண்ணிட்டு அது just a few 2 minutes தான் ஆகும் அது.
Okay.
Any desk.
Just
Normally and the share screen
just 2 more minutes.
Yeah. So others kindly install the orange. Yeah, connect. Allow access. Sir, are you able to see my screen?
Yes, ma'am. Is it visible, ma'am?
Yeah, see now. Share screen option. Put the share screen option, sir. Ask to disable.
Yes, ma'am. Is it visible, ma'am?
What's that? What's that?
You have shared the screen, ma'am.
Yeah. இது ஒர்க் அவுட் ஆகல கரெக்டா. Something is missing. What to do? It's இது நான் ஆஸ்டா இருக்க, நீங்க ஆஸ்ட் இல்ல, அதனால உங்களோட ஜூம காமிக்குதுன்னு நினைக்கிறது. This is not going to work out. Okay sir, any desk வெட்டுருங்க நீங்க, அது வரல கரெக்டா. இல்லாட்டி உங்களது எடுக்க பாக்குறேன் நான். So உங்களோட எனி டெஸ்க் நம்பர் சொல்லுங்க. கார்த்திக் சார், கார்த்திக் சார். Because only when we see that visualization, it's really impactful. And when I show the data table, it will be showing the records and the table every exact or other show. Similarly, each and every time another window will be popping. Ma'am, ma'am, hello, Karthik sir, let Google link கொடுத்துருங்க. Hello.
Ma'am, shall I share the any desktop number, ma'am?
இல்ல சார், கூகுள் லிங்க் கொடுத்துறேன். பி மீட்டிங் இன்வைட். So dear participants, kindly join this Google Meet link, please.
Post the Google Meet link here, ma'am, so that we can tell the participants to come over.
Start now. So I've shared it. So kindly all the participants move to the Google Meet link, please.
Yeah, thank you, ma'am.
Yeah.
For the participants, please kindly excuse for the technical difficulties. Let's continue the webinar in the Google Meet. Please go to the Google Meet, throw the link even in the chat. Dear participants, kindly go to the Google Meet. Now you can join the, now you can continue the session in the Google Meet. Okay, kindly join the Google Meet or in the chat. I request all the participants to go to the Google Meet. You can click in the chat room. Google Meet, sir. Google Meet இது பண்றேன். So dear participants, the webinar has been moved to the Google Meet. Kindly go to the Google Meet through the link given in the chat room. So if you're not able to see the Google Meet link, you can post the message in the chat.
ಗಣೇಶ್ ಮತ್ತೆ
Dear participants, kindly go to the Google Meet. Link has been given in the chat. சரி சார். சரி சார். சார் மீட்டிங் வந்து கூகுள் மீட்ல மூவ் பண்ணிட்டு இருக்கு சார். ஸோ கூகுள் மீட்ல மூவ் பண்ணிட்டு இருக்கு. சாட் ரூம்ல பார்த்தீங்கன்னா அதுக்கான லிங்க் இருக்கு.